Okay, today we're talking about R2 fractions. Alright, so introduction to fractions. Fractions are numbers written in the form A over B, or A divided by B, where the numerator, the top number, and the denominator, the bottom number, are whole numbers. It is important to note that the denominator can be 0. I'm sorry, that the denominator cannot be 0. Sorry. We say that the denominator B is non-zero, or that B cannot be equal to 0. Okay? So here's our definition of a fraction. A fraction is a number that can be written in the form A over B, where A and B are whole numbers, and of course basically repeats what I just said a moment ago. All right, so back down here. Fractions can be used to indicate parts of a whole. For example, if a whole candy bar has 7 equal parts, then the fraction... Oh, okay, good, I did. Forgot, I didn't know if I recorded or not. If a whole candy bar has 7 equal parts, then the fraction 3/7 reads 3/7. Indicates that we are considering three of those parts. Oh, there we go. 3 of those parts. So this little figure of fractions, right? This particular candy bar has 7 parts, but if you're denoting 3 of them, then we say that you have 3. That we're looking at 3/7, right? So I don't know about you, but I would much rather have the 4/7 parts of that candy bar. Ready? So example 1, understanding fractions. Example 1 reads, write a fraction indicating A, the shaded part of the rectangle, and B, the unshaded part. Okay. Now obviously you can see the answers down here, but we're just going to go with this. Okay. So example 1, we see we have four rectangles. Okay. The shaded part, 3 of those 4 are shaded. So therefore we would say 3/4 are shaded. Now on the other side, we say that 1/4 is unshaded. I'm sorry. Yeah, the 1/4 is unshaded. And I mean, I guess that's it. That's about as easy as it gets. Okay. Proper fractions and improper fractions. A proper fraction is a fraction in which the numerator is less than the denominator. Okay. So examples of a proper fraction, we see 2/3, 7/8, and 32 over 60. These are proper fractions because the number on top is smaller than the number on bottom. Improper fractions is, well, kind of the opposite there, right? The numerator is greater than or equal to the denominator. Okay, so we can see that 15 over 8, right? 15 is indeed bigger than 8. 14 is the same because it says greater than or equal to. And then 250 is obviously indeed larger than 100. So whole numbers can be thought of as a fraction with the denominator 1. Thus, in fraction form, so 0 is just simply 0 divided by 1. We can think of 0 divided by 1, and we'll see that later on in the section. 1 is 1 over 1, 2 is 2 over 1, 3 is 3 over 1, and so on, right? 96 is 96 over 1, right? Fraction notation indicates division. For example, 24, and then this fraction sign here, it indicates division. So 24 divided by 8 can be written in the form 24 over 8, which indicates the numerator is to be divided by the denominator. Right. Now we're going to start something that I'm pretty sure you're not abundantly excited about. We're going to be talking about multiplying and dividing the fractions. Sorry, multiplying and dividing fractions. Okay. Well, in order to multiply fractions, and I believe we can start the snipping process here. I'm not sure whatever. Alrighty, so multiplying fractions. So looking at the box up here, in order to multiply the fractions, right? We see that we have this example here is just simply A over B times C over D. Okay. Well, it looks like the procedure is we just multiply the two numbers on top. Well, maybe I should just circle that. We just multiply the two numbers on top with the two numbers on bottom, and that's it. I say that's it. That really is it. But I mean, the complication arises from the multiplication part, right? Because I mean, sometimes your brain's just tired and you don't know what 3 times 7 is, and that's just life. Right, but let's just do 3 times 7, right? So with this particular problem, we have a 1/3 times do this times 2/7. Okay. Well, the way this up here tells us we should do it is that we should basically say 1 times 2 over 3 times 7. Okay, my stylus ain't working too hot right now. That's all we did. We just simply went across there, right? So 1 times 2, that's easy. That's just going to be 2. And 3 times 7, that's pretty easy. Well, for me, I guess. It's 3 times 7 is 21, right? That's it. That's how you multiply fractions. It doesn't get too much harder than that. We're going to hand wave example 2. Wait, that wasn't going to. We're in hand wave example 3. Right. We'll just follow along, but then I'll do number 4. Okay. So example 2, we see it says find 2/5 of 3/7. Okay. So what I'm going to do is I'm multiplying them together. So we have 2 over 5 times 7 over 3. Well, we just multiply the numerators, which is 2 times 7 is 14, and 5 times 3, which is 15. And that's it. That's as hard as it gets. Right? Now let's jump to example 4. This one, I wouldn't say it's harder, but I mean, it's newer, right? Newer things, different things. So let's start with A. Okay, we have a 4 over 13, and it says times 3. But earlier we said that we can represent 3 as 3 over 1, right? So all I'm doing now is I'm just going to be multiplying 4 times 3 and 13 times 1. That's it. So 4 times 3 is 12 over 13. All right, real quickly. Well, no, let's just finish this up. 13 times 1 is 13. Okay, now real quickly. All right, so if my pen does work correctly, I generally like to write my 1s like this. My 7s look like this. That's the difference, okay? I write my 1s with a little flag here just to really denote the difference between, 1 and an absolute value sign or something, okay? So if you see it like that, that's what that is. But when it's small, like this, well, like these numbers, they're a little bit smaller. It's kind of hard to put a flag on the smaller numbers when I write it on this blackboard, because it comes out looking like that little bit right there. Okay. So anyways, there's that. All right, B. Okay. So B is 9 over 8. And then it's times 0. Okay, well, times 0, we know times 0 is just simply 0 over 1, right? Well, 9 times 0 is 0. And then 8 times 1 is 8. So let's just go ahead and do this real fast. 9 times 0 is 0. And then 8 times 1 is 8. Okay, well, but 0 over 8 is just going to be 0. Okay. Now we're going to go to C. We're going to go to a big one. We're going to put in a different color. Probably should put B in a different color too, but we'll just live with it. Okay, so we have 4/3, so we're going to say 4. Okay, we're going to write this out combined already, okay? Because the problem is written, in multiplication form, right? 4/3 times 5/3 times 2/7. So what I'm going to do is I'm just going to multiply all the numerators. So 4 times 5 times 2 all over 3. My 3's always mess up too on this blackboard. 3 times 3 times 7. Okay. Well, what is 4 times 5 times 2? Well, 4 times 5 is 20. 20 times 2 is 40. Okay. 3 times 3 is 9. And 9 times 7 is 63. And that's it. 40 over 63. Okay. So that's those problems. Alrighty, finding equivalent fractions. Right. So starting here, this reads, I don't know if y'all can hear my, let's see, 9:30. Hang on, I'm going to write this down because I have colleagues out there laughing and stuff. I was wondering if you guys can hear that. So at 9:30 in the lecture. Check that out. Alrighty, so next up we've got defining equivalent fractions. So The number 1 is called the multiplicative identity for whole numbers. That is, a times 1 is equal to a for any whole number, which makes sense, right? Anything times 1 is itself. The number 1 is also the multiplicative identity for fractions, since we know that a over b times 1 is same thing as saying a times 1 over b times 1, which is simply a over b. Okay, so anything times 1 is that anything, right? Now, if two fractions are equal, they're called equivalent fractions. To find an equivalent fraction, we first need to know that one can be represented in a fractional form with any counting number divided by itself. Okay, so this means that to find the equivalent fraction, we must multiply the numerator and the denominator by the same number. So that probably doesn't mean too much to you. So let's go ahead and let's snip this example. Obviously, again, you can see the answer, right? But that's not the point here. The point is we're going to talk our way through this. All right, so we've got 3/4. Let's make it a little bit larger for you. Don't know if this helps at all, but there it is. Okay, so we got 3/4 is equal to something over 36. Okay, well, in order to figure out what that something is, here's what we have to do. Okay, so we have, heck, let's just go ahead and rewrite it. It's equal to something over 36. Okay, so just looking at the left side here, the left side is strictly just 3/4, right? It's 3/4 of something. The other side is going to have to also be 3/4 and for it to be an equivalent fraction, right? If something is 3/4, then something that's equal to it is also 3/4. It might not look like it because the numbers are going to be different, but the numbers are still going to be 3/4. What I mean by that is 3/4 and 75 over 100, they're equivalent, right? Because 75 over 100 is 3/4, right? 75 is 3/4 of a dollar. 75 cents rather. It's 3/4 of a dollar. They are indeed equivalent. So that's what we're trying to do here. How do we figure out what that question mark is? Well, what we do is we're going to look at this the numbers that we do know, the denominators, the numbers that we do know. And we're going to say 36 divided by 4. Okay? Well, 36 divided by 4 is what? It's 9, right? So 4 goes into 36 9 times. Therefore, this number here must be 9 times greater than the 3, right? And 9 times 3 is 27. So we know that this question mark is going to be 27. Okay? And that's how we do equivalent fractions. Looks like we have an example 6. That might be another good one. Okay, so we've got 11 over 10 is equal to question mark over 50. Okay, alrighty, well, looking strictly at the denominator here, okay, 50 is 5 times greater than 10. So therefore, I must multiply this by 5. So 5 times 11 is 55. That's equivalent fractions. Alright, so reducing fractions to lowest terms. Alright, so finding an equivalent fraction in lower terms is the same as reducing the fraction. A fraction is reduced to lowest terms if the numerator and the denominator have no common factors other than 1. To reduce a fraction, we again use the fact that 1 is equal to any counting number divided by itself and divide out all common factors found in both the numerator and the denominator. Again, these are just words to you, right? So let's figure out a way we can chug through these words, right? So by doing that, let's chug through example 7. Right, so we need to reduce this fraction to lowest terms. So what this means is, like the 75 over 100, right? 75 over 100 is a fraction, right? But we can reduce that to 3/4. Same can be said for all these that we just did. Well, not all these, all 2 of these, right? 27 over 36 can be reduced down to 3/4. 55 over 50 can be reduced down to 11/10. So that's what we're doing here. 16 over 28 can be reduced. What can it be reduced to? Okay. Now, obviously, you probably could figure it out on your own, right? Because this is a simpler one. But we're still going to do it, I wouldn't say the hard way, but we're still going to do it the more concise way, right? So what we're going to do is we're going to, if we were to do the prime factorization, if we did a prime factorization tree of 16, right, we would say, 2 times 8, 8 is 2 times 4, 4 is 2 times 2, okay? So it's 2, 2, 2, 2, so 2 to the 4th power, right? So I know that 16 can be represented as 2 times 2 times 2 times 2. Right? I also know from prime factorization of 28 that 28 is going to be 2 times 2 times 7. Okay. Now again, this is just something I know, obviously, but if we were to play this out, and I'm not going to do this with every example that we do here with the prime factorization tree, but I know that 2 times 28 is 2 times 14, and 2 times 14 is 2 times 7. So 2 times 2 times 7 is my prime factorization. Okay. So once I got my prime factorization out of the way, I need to just simply kind of cancel, right? So what I mean by that is, well, these cancel, and that's it. So my solution here is 2 times 2, which is 4, and then 7 times, 7 by itself is 7. And that's it. 4/7 is the same thing as 16 over 28, it's just reduced. Okay. Now another way to go about this, and this really only works if you have something that's even numbers, and of course there are other ways to do it by divisibility of 3, 4, 5, so on and so forth. But 2's, right? 2. If I did 16 divided by 2, that's 8. 28 divided by 2 is 14. Well, 8 is also divisible by 2, which is 4, and then 14 is also divisible by 2, which is 7. So there are other ways to go about it, but the way that I demonstrate on the blackboard is the super duper concise way to go about doing it. Okay, so let's do another one. Yeah, there we go. Okay, so this says reduce 45 over 36. Okay, well 45 I know is 5 times 9. Well, 5 times 3 times 3. In 36, I know is going to be 3 times 3, let's put it sign here, 3 times 3 times 4, no, sorry, I'm trying to get ahead of myself here. Alright, this will be better. So, in this particular case, I did do the prime factorization. It did reduce down to something easy peasy, okay? That's because it was divisible by 2. And of course I said a shortcut you could do is say 16 divided by 2 is 8, and then 8 divided by 2 is 4, and then 18, and then the other way with 28, you can do it twice as well. Okay, in this particular case, we're going to do a little bit different, okay? We know that 45 can be divisible by, or is the same thing as 9 times 5, right? Well, 36 is also 9 times something, is 9 times 4. Well, similar to what we just did, we could say, okay, the 9's cancel, and then we're left with a 5 and a 4, 5 over 4. Okay, so instead of getting the complete prime factorization tree, which we could have done, and you know what, let's just go ahead and do it. Just kind of get it out of the way. Let's put it in yellow here. We have 45. Oops, that's not right. 45. Okay, 2 doesn't work. 3 does work, so 3 times 15. 15 is 3 times 5. Okay, so I could say that 45 is 3 times 3 times 5. And 36 is, okay, again, I don't mean to do that. We put the branch there, so 2 times 18. And then 2 is prime. And 2 times 9. 2 is prime. And then 3 times 3. And they're both prime. So we could say that is what? 2, 2, 3, 3. So 2 times 2 times 3 times 3. Okay. And then same procedure as we've seen above. Well, the 3, 3, 3, 3, 3, 3, those cancel. And what we're left with is a 5 in the numerator, and then 2 times 2 in the denominator, which is 4. Okay, so we can get there either way. It's just instead of having to reduce the 9 down to 3 times 3, and then canceling out the 3 times 3, I know that I can cancel out just simply the 9s. Okay, so there are other ways to go about doing things, and obviously shortcuts can be had. Okay, so that's example 8. Same procedure there. Okay, so example 10 looks like it's to be fun. Honestly, yeah, well, I'm trying to figure out if it's just kind of a redundant example or if it's something that's new. And I think it's new, so we're going to do it. Okay. Excuse me. All right, so multiply and reduce the two lowest terms. Okay, so we have a 17 over 50, 25 over 34, and then an 8. Okay, so how do we reduce this? Okay, well, we could say, and it looks like so 17 over 50, we could say 50 is 2 times 25, right? 2 times 25. And we're going to leave it like that because, notice the second term is 25 over 34. Okay, so we're going to say times, and we're going to leave the 25 in the numerator. Oops, let's make that a little prettier. Like I said, my multiplication signs on here kind of suck. All right, so we're going to leave the 25 in the numerator. And then the denominator, I know 34 is the same thing as saying 2 times 17. Okay, and the reason I'm doing this is because I want the 17s to cancel and I want the 25s to cancel. So I'm not reducing as far as I can. Okay, and then 8. Okay, again, 8 can be written as 8 over 1, right? But what we're going to do instead is we're going to reduce the 8 into a 2 times 2 times 2 over 1. The reason for that is the same reason why I kept the 17s and the 25s in place, is so I can cancel out a 2 with a 2 and a 2 with a 2. Okay, now that does seem really fast, really quick, but as you do this, as you practice, you're going to see patterns. You're going to recognize patterns, and you're going to be able to do this pretty quick, I believe. Okay, so with that said, honestly, I probably should have kept my marks, but I wanted them all red, right? So my 17s cancel, my 25s cancel, this 2 cancels with this 2, this 2 cancels with this 2. Okay, so all of this doesn't matter, all of this doesn't matter, and so I basically just have 2 over 1, or in other words, just simply 2. Okay, it's that easy. Once you get the hang of it. All right. Next, we're going to do dividing with fractions. Okay. Now, this is the part that I know you're not going to like. You know how I know that? It's because I don't like it. I've been doing this a long, long time, and I still don't like it. Right? It's just fractions. Nobody likes fractions, but we have to just dive in. Okay. So let's start from the top here. If the product of two fractions is 1, then the fractions are called reciprocals of each other. For example, 5/8 and 8/5. Okay, if I multiply them together, 5 times 8 is 40, 8 times 5 is 40, right? And then 40 over 40 is equal to 1. They're called reciprocals. Okay, if the two of them are multiplied together and you get 1, they're called reciprocals. And basically what it is you take one fraction and then you flip it upside down. That's it. That's all a reciprocal is. Right? So this reads, the reciprocal of A over B is B over A. That's pretty easy. Okay. Now to divide fractions, this is a big deal, and we're going to snip this along with our example here. Okay. So to divide by any non-zero number, multiply by its reciprocal. In general, right, we see this. A over B divided by C over D is equal to, the A over B stays the same, okay? It's equal to A over B, but what we're going to do is we're going to notice how we change the division sign to a multiplication sign, and then we flipped the C over D to D over C, okay? So you've probably heard this phrase, we are going to multiply by the reciprocal, okay? So let's, real quickly, let me tell you something kind of cool here. I have calculus students that, you know, because if you don't use it, you lose it, right? That'll look at this problem here, right? That particular problem is pretty much the same thing, saying 2 over 3 over 5 over 8, right? Something like this is, I mean, admittedly kind of intimidating, because it's like, oh great, I got a fraction over a fraction, right? It is kind of intimidating, but if you break it down and make it look like this, it's a lot easier. Okay, so I don't know. You might forget too whenever you get to calculus, but you won't be alone. Okay, so I'm going to go ahead and rewrite this. So it's 2 over 3, but I'm going to multiply by the reciprocal. The reciprocal being 8 over 5, and that's it. 8 times 2 is 16. 3 times 5 is 15. We're done. Right? It literally is that easy. And I say that, having said, I also hate fractions because, well, I still do, because I don't like to do this, right? It's just part of it. So I've got 3 over 4, and then it is written divided by 4. Okay, but we also know that 4 can be written as 4 over 1, right? So I'm going to multiply by the reciprocal. What's the reciprocal of 4 over 1? Well, it's 1 over 4. So I'm going to get rid of that division sign, turn it into a multiplication sign, and say 1 over 4. Okay, well, what is 3 times 1? Well, that's 3. What is 4 times 4? That's 16. So 3 over 16. Right? That's it. Right? 13. Okay. So this reads, again, it's probably small. They're all probably small. I'm sorry. It's just a textbook. This says divide and reduce the lowest terms. So 16. So let's go ahead and just begin the process. So 16 over 27 multiplied by the reciprocal, which is 9 over 8. Okay. So what we're going to do is we can obviously bust out the calculator and figure out what 16 times 9 is and what 27 over 8 is. Or what we can do is we can say that, or we can kind of reduce this to something that's easier to translate. And what I mean by that is we're going to figure out, because we know that 16 and 8, they can reduce, right? Because 16 is twice 8. All right, so instead what we're going to do is we're going to rewrite 16 as 2 times 8. Okay, and we're doing that specifically so the 8s will cancel, and you'll see that here in a moment. And then 27, we're going to write 27 specifically as 9 times 3. And again, we're doing that specifically so we can cancel the 9s. Okay, so that whole thing I was telling you about is right here, like literally 4 seconds later. Okay, so the 8 here and 8 here cancel, the 9 here and the 9 here cancel. What am I left with? Well, I'm left with just simply a 2/3. Okay, so again, it's just getting used to what you see. Not what you see. It's getting used to the numbers. And again, many of you probably already have your multiples down already, but that does conclude the review section 2.